Hello everyone, welcome back. And so in this video, this is a continuation of the previous video where we discussed the introduction to Java. And here we are going to discuss the classes and object concept, right? So what are objects and classes? Objects are like things around you. Everything around you, you can relate it as an object and class. For example, your bike, your dog, your video game characters, all are objects. Classes are like a blueprint of or plans to create objects, right? For example, cake is an object and the recipe is a class. So out of that same recipe, you can make many objects, you can make many cakes. You can take it up like this. So class is basically a blueprint and objects are the photocopy or the different version of that blueprint together. Okay, so let's move ahead. So as you have understood now what is a class and what is an object, so the objects do have a properties. There are certain main properties of these objects and classes, right? So the four main very important properties of objects and classes are the first one is encapsulation. Now, as the name says, encapsulation is something related to a capsule, right? So you think it's of a capsule like a pill, right? Inside that you have a medicine, and no one can see that medicine when you engulf it. It goes into your system, right? So in programming, encapsulation means keeping the details or the date. What are the details, the data, and the code inside, right? So an object basically hides the data and the code from the outside world. It does not hide everything. It only hides the thing which is required, okay, which you set it as to be hidden and which you want it to be shown to the public. That you can adjust it by some keywords like public, private, and protected, which you are going to learn as you move on in the series, right? So the first property is encapsulation, which actually encapsulates the data and code inside it. Second property is abstraction. All right. Now the abstraction means imagine you have a TV remote, you press a button to change channels, right? A volume button can increase the volume, a channel button will give you a sports channel and so on, right? Now to use that remote, you need not to know what are the details circuit of that particular remote. You only need to know which button to press and how which channel it's going to start, right? So this property is called abstraction, right? So like hiding something and showing the things which are required by the user, right? So actually you can think all these properties are interrelated. You can think of like encapsulation. Encapsulation is covering, so abstraction is hiding. Now hiding will only happen when you have a covering, right? So abstraction is the property using which you hide certain things and show the other details. So in programming, abstraction means hiding complex details and showing only which is necessary. It, it makes using the object easier without knowing all the details inside it, right? So inheritance is a properties using which you share one thing to another, right? For example, you inherit your height, your hair color, your eyes color from your parents. So similarly, when a class in programming, when a class shares its properties to other class, it's called inheritance, right? And what are the properties of a class? The properties of a class are its methods and variables. Okay. So the next property, and so the next properties and the fourth properties of classes and objects is polymorphism. Now, polymorphism, where poly means many and morphism means existing, right? So when something exists in more than one form, it's called polymorphism. Or you can say when a function can do more than one kind of work, it's called polymorphism. For example, suppose you can drive a bike, you can drive a car, you can drive a plane also. So they all are different vehicles, but you are the same. So you, as a person, the same person can function in many ways. So this is called polymorphism. So in programming, when one function or method can do different kind of works, it's called polymorphism. Let's take it an example. Suppose you have created a function move, and so when you are using this move function with reference to a car, so that means driving a car, right? Moving a car means driving a car. And when you use it with reference to a bird, then moving a bird means flying the bird, right? And when you use it with reference to a fish, then moving a fish means swimming a fish. So the same function move is doing different uh, ways, can be used in different ways. This is called polymorphism. When we do the coding part, I guarantee you this will be very much clear to you. Okay. So now next, recall everything. So whatever we have learned so far or we have discussed so far, that's the object-oriented programming concept, or we call it a OOP concept. There's another approach to the programming, which is called the procedure-oriented programming, which is POP. Now, in object-oriented programming, the main focus is on objects, whereas in a procedure-oriented programming, the main concept is on procedure. Procedure are the methods, right? Let's first discuss what are their points. So, the POP basically focuses on function or procedures. Think of it as a list of instruction steps to perform a task. A function is nothing but a step of instructions. So most of the code in our POP are written in form of functions. Organization, in terms of organization, the main focus is on writing procedures and functions that operate on data. Now, data and function. Data is usually separate from the functions. The functions act on data, but the data are not tied to them. Okay. So functions work on data, but data are not connected or linked to the or binded to the functions. Example, cooking from a recipe, right? So cooking from a recipe. So here, the same recipe can be used to make different dishes, right? So recipe is what? Are steps, are steps to follow. Okay. So object-oriented, whereas in object-oriented programming, the focus is on objects. These objects are instances of the class, which are like blueprints, which we have discussed already in the previous few minutes. Organization is focus. The main focus is on creating objects that contain both data and function. Data and methods. Now, data and functions called methods are bundled together inside objects. Okay, so here data and methods in object-oriented programming are together inside connected to an object. Example, building with Lego bricks. So each brick, you can take it as an object, has its own properties and function, and you can combine them to build something complex, right? Now, these are the points of these two types of programming. Now, what is the difference among them? So the key differences in the form of structure is POP programs are divided into smaller parts called functions. As we told you, the name is procedural oriented programming, so they write the full code is written in the form of functions. Whereas the object oriented programming, programs are divided into objects. Each object contains data and methods. Okay. When we do practicals, this will be much more clear to you. Right now, you can just imagine what is happening. Now, data handling. On the basis of data handling, the POP data is usually passed between functions, and functions don't belong to the data. We know that data is not related to the function. Whereas in object-oriented programming, data is tied to the object. So methods belong to the objects and operate on their data. So this is a very important point. In POP, the data is not related to the function. Function works on the data, whereas in object-oriented programming, the data is linked to the object, right? Now, reusability. Reusability means you can use the same set of code again and again. So POP, reusing code can be harder because you might have to copy and paste function. Reusing code in POP means you have to copy and paste the same function and then use it again. But whereas in case of object-oriented programming, you just create another object and call the same method again. You need not to copy, paste, or retype the code. That's the advantage. Okay. Now, security. POP less emphasize on data security, so function can access or modify any data. In POP, security is very less because there's nothing called public-private protected access specifier. Whereas in object-oriented programming, we have just discussed the encapsulation, the abstraction properties, which makes the data to be more secure. Right? Real world connections. Now, POP, it's hard to connect a real world thing with a procedural oriented programming, whereas in object oriented programming, it's very easy to connect any real world thing into object oriented programming. What does I mean by that? Let's pick an object from around you. You must be holding a pen. So let's take a pen, right? So you have a pen. Now, the pen has some properties. What are the properties of pen? The color, all right, and the size and the make. So these are the properties or the data. Okay. Now, what does the pen do? Pen write. All right. Now, write is a function. Now, you can easily connect because everything around you would have a property and would have a function. So, you can easily connect anything around you with properties and functions. And that's why it's very easy to use or connect object-oriented programming. And that's why it's very popular, actually. Right. Now, introduction to Java. How do we work on Java? We have given in the previous video what is Java and all those about. Now, technically, what is Java? So now types of Java programs. There are two main types of Java programs. The applets. Now applets are small Java programs that run inside a web browser. Think of them as a mini apps embedded in a web page. So basically, applets are for the web pages or for the browser. For example, a simple animation on a web page. So the animation which you see on the websites are are because of the Java code, and those Java codes are called applets. Now, applications are the big programs which run on its own. I mean, not on the browser, they run on its own. So that they are written in a Java language. So applications are standalone programs to run on your computer. These can be anything like a game or a software tool, example, a calculator program on a desktop. That's a application, standalone application. Now, as we discussed in the previous video also that when you write a code, that code is called a source code. The code written by the user in any computer language, here in Java language, is called a source code. Now that source code the computer does not understand. The computer does not understand what is a Java or what is a C or what is C++. Computer only understands the zeros and one the signals of high voltage and low voltage. Now, there's a program called compiler which actually converts your uh, source code, the code written in any language, to the byte code, which is in the signal form. Okay. So first you write a source code. You write a source code with a enough file, like you can also write on a notepad with the extension .java. Example, you can write a code like hello world. Okay. Then you compile the source code. When you compile the source code, it gets converted. Suppose the file name is hello world.java. All right. So when you compile it using the compilation process, it will create another file. It will create a file called hello world.class. So this is the intermediate file which will be created out of this. Now further, the bytecode, the Java virtual machine, uses that bytecode and runs the executable code. So after this, technically, one more file is created, which will have the names hello world.exe. That is the executable file. And using that file, the Java virtual machine runs the code, follows the instruction. Runs the code means follows the instruction. Now, important terms, the source code, the source code, the human readable code with a .java file, that's called a source code. Public class hello world, so public static void main string argument system.out.world. So this is a simple example of a Java code, right? So it starts with public class hello world. So this is a file name. Class you have to write every time whenever you create a Java code. Public static void main, this is a function inside which what you are doing, you are trying to print this message on the screen. So system.out.println hello world, this is a message which is to be shown on the screen. So this is the source code. This code is the source code. Now when you convert this into byte code, right? Now what is the byte code? The compiled version of this Java code in a dot class file. Okay, it looks like a gibberish human language. You can't understand it when you try to open it. It just gives you symbols and some weird symbols. So that's kind of gibberish things, right? So I hope this thing is clear to you. What is Java and so far, what is Java, what is source code, what is bytecode. Then now what is the object code? So in Java, this is same as a bytecode. In the other language, it can be machine code specific to a computer processor, right? So the bytecode or object code is same in Java, but in other language, they are differently placed. Now, what is a Java virtual machine? A program that runs Java bytecode on any computer, right? As we know, Java is platform independent. You can run the same code which you did on Windows to any other computer, any other operating system like Android or iOS without retyping it, without recoding it. So That happens because of the JVM. The JVM allows Java program to be platform independent, meaning they can run on any OS. The features of Java, it's simple, easy to learn, syntax is clean, and this all we discussed in the previous videos. Also, robust, it's a secure, the object-oriented platform independent. Example of a Java program. Now here you see the code which I have just written in the above example. It actually has to be written in this format, right? So this is the way, this is the syntax it has to be written. So you'll start with a keyword public, then class has to be typed every time, and this can be changed because this is called the file name. Okay, yes, this is your file name. So this would be saved into the program into a file called hello world.java. Sorry, hello world.java. Okay, and what you have written inside this code, this is a function, this is a method. Inside this method, this is a method. Inside this method, you are writing a sentence which says that system.out.print. This statement is the output statement, which is going to print anything on the output device. What is the output device of a computer? It's monitor, right? So it's going to print this message on the screen on the monitor. Now, after typing it, you just have to save this as a hello world.java, I told you. Then compile it with a compiler. If you're using a ready-made compiler, like if you're using something called BlueJ, which we would be using it, then you just have to click on the compile button. It does everything, every other Java. And if you're using the console, then you have to type javac and the program name. Okay, and then you have to run it by this. But when in BlueJ, you just have to compile, and it compiles, and then you just click on right click and run. It runs. Okay, I'll show you how to do this, of course, in every other in next videos. Now, the applet, the another kind of program, which is written, both are Java languages, but that is the Java code, and this is the what you call it, the JavaScript. Okay, so when you write an applet, you just have to import the Java applet class and the graphics class. And here, what you're doing, you are creating a class, hello world applet, extends applet because it so that it connects to this particular file. Then white paint, so you created a function paint. What it is doing is just going to write this particular thing in the on the screen with this dimension, with the rectangular with dimension 20 and 20. So with 20 and 20 dimension, it's going to write hello world on the screen. Yeah. Save this file by the name hello world applet.java, compile it, and then view it on a applet viewer. So then this would be visible on the applet viewer, which is basically a browser. Now, what are the steps in compilation process? You have to write the source code. You have to save your code by the .java file. You have to compile the source code, which converts your program into the bytecode. And then you have to run the bytecode. So the JVM, the Java Virtual Machine, actually executes your bytecode and follows the instructions, which is written in the program. Now let's recap what we have done so far. So source code, which is the original code written by the programmer. Bytecode, the compiled version of the source code, which has extension .class. Object code, the machine code that a computer processor understands in Java. It's essentially a bytecode only. And JVM, the Java Virtual Machine, the system or the program which actually makes the Java code platform independent. Okay, now the features. Simple, Java is simple, Java is robust, it's secure, object and platform independent, right? I'm just covering each and every point here theoretically because it is in the syllabus of the Icse. So on the way, this can act as a notes to you. I'll put it in the description, the full document I'll add on the description so you can download and keep with you. So thank you very much for giving your time and press the like button if you like the video and also subscribe and share. This will help a lot to the channel and so that I can produce more and more videos similar to this. Take care.